Welcome everyone to JADAK's Introduction to Medical Machine Vision webinar. My name is Justina Valencia and I'm part of the marketing group here at JADAK North America. On the line we will also have our Director of Global Marketing, John Pryor, who will give a brief overview of JADAK and our parent company Novanta before handing the mic off to our Director of Product Management, Chuck Barber, who will walk us through his presentation. Today, we will review what is machine vision, look over some medical machine vision case studies, take a look at what a medical machine vision project looks like, as well as exploring JADAK's medical machine vision package Clarity. We encourage you to type in any questions you may have into the chat window during the webinar so I can read your questions aloud to Chuck. We'll do our best to answer all your questions. However, if time does not allow it, we'll email you back the answers to your questions. So now, without further ado, I'd like to hand the mic over to our VP of Global Marketing, John Pryor. John, take it away.
Thanks, Justina, and good morning, everybody, or good afternoon or good evening, depending on where you're joining us in the world. So Justina said, my name is John Pryor. I'm the Global Marketing Director here at JADAK, and for those of you who aren't familiar with JADAK, I'm just going to do a sort of a brief overview of who JADAK is and what we're all about, and then I'll turn it over to our featured presenter, Chuck Barber. So who is JADAK? JADAK specializes in embedded machine vision, RFID, barcode, printing and computing products, primarily for the medical device industry or medical device manufacturers. We do offer off-the-shelf data collection products, but the vast majority of our projects are optimized solutions, optimized data collection solutions for specific OEM needs and customer requirements. As you can see here, we have a long history in the healthcare market. So today, approximately 90% of our business is with medical device manufacturers. We are ISO 13485 and 9001-2008 certified. And we're a proud healthcare market leader. As you can see here, we're the leading provider of OEM imaging engines to blood glucose meters and portable analyzers, as well as infusion systems. And in fact, we're the #1 leading supplier of imaging engines to the healthcare market overall. Next bullet here kind of deals with our scanning product, our core scanning product. We offer the #1 scanner used with patient monitors, ultrasounds, and infusion pumps today. So the majority of these systems in the field today are using this product down here to the right. As you can see in sort of presentation mode here, scanning a pill bottle, that is our HS1 hand scanner. And that's you'll find those all over the healthcare environment used on patient monitors, ultrasounds, and infusion systems. And we're proud to have been one of the first to implement embedded machine vision solutions into medical devices such as clinical analyzers and surgical machines, amongst others. We're really pioneers in this space. And then this last bullet here, scientific R&D. So we're recognized as the expert in color measurement, and that really stems from a recent merger with a company called Photo Research. Photo Research has been in the light and color measurement industry for nearly 70 years. So today, we're finding a lot of interest from our clinical equipment manufacturers to embed spectroscopy modules inside of their devices for precise color measurement. So we're leveraging Photo Research's expertise here specifically for these applications. So some additional business information about JADAK. We are a Novanta company. If any of you were familiar with a company by the name of GSI Group, Novanta is formerly the GSI Group. Novanta actually went through rebrand this past summer. So we are Novanta now. We are traded on the NASDAQ, and the company is approximately $400 million in revenue overall, with about 1,400 employees across the globe. As you can see to the right here, the company is split into 3 core technology segments. So in the left column there, you've got our laser products, or our photonics division. This division offers cutting-edge solutions for high-performance, high-precision laser-based surgical and analytical tools for fine material processing applications. Over on the far right, our precision motion group. So this group offers solutions such as optical encoders and direct drive motors for complex motion control applications. And really what you think about here is like a robotic surgery type applications where that surgical arm needs to move in very, very precise measurements and in precise positions down to nanometers and microns, really. So that group is responsible for that segment of Novanta. And then you've got in the center here the vision group where JADAK sits. Our group is a leading supplier of technology solutions with the overall goal of giving advanced industrial and healthcare OEMs a competitive edge in their marketplaces. So that's sort of the quick overview or high-level look at JADAK. And with that, I'm going to hand it over to my friend and colleague here, Chuck. Chuck, the floor is yours.
Thank you. Hi, my name is Chuck Barber. I don't know if I've met anybody on the phone here today, but that's my mug there on the left. You can see from my bio, I won't go through the whole thing. I've got over 30 years experience in technology development and management, about 20 years of that in what we call automatic data collection, primarily in image-based collection systems. So barcode and machine vision has been my areas of expertise. So that's who I am, and that's my background. And without much more said, we'll get right into the meat of the presentation here. So what is machine vision? We're going to start out really with some definitions and give everyone some background. So machine vision refers really to the act of acquiring an image and using algorithms to extract some information from that image. So automated algorithms, software. You can see from the graphic here, here's an example of what we do in machine vision all the time. So we're looking at some objects and we're extracting some information about those objects. You'll hear machine vision referred to as image analysis, computer vision, other words like that, but that's essentially it. If you look in the blue call-out down in the lower right corner, we'll further divide machine vision into two categories, what we call active machine vision, and that's where the target that is being imaged, the thing that you're looking at, was really sort of designed to be read by machine vision. So good example of it is a barcode. So barcode is a form of machine vision. You're using a camera to automatically decode that barcode, but why we call it active is that barcode was designed to be read by a machine. The other category is passive machine vision, and that's primarily what we're going to deal with in this presentation. Passive is where you're looking at some object, and it wasn't originally designed to be read by a machine. So in a lot of cases, we're taking a look at some object that formerly a human would look at and make some judgment about, but now we're going to transfer that over to a machine. Is there a question?
Oh. Yeah, we actually have a really interesting question on the line. The question is machine vision basically the same technology used in facial recognition?
So the question was, is machine vision technology really what's used in facial recognition? And that is. So in that case, you're taking a picture of an object, a person's face, and you're trying to automatically determine, you're going to compare that face or some portions of it to a database and determine, is this person on your watch list, or is it the allowed person that's allowed access to the room or whatever? So that, yes, it is. That's a good example that a lot of people are familiar with. I'm going to move on again, and let's get that off the screen, where we have, we're going to further define the difference between medical machine vision and industrial machine vision. So on the right, we have industrial machine vision, and this is what a lot of people think of when they think of machine vision. You think of some kind of assembly line where you're going to have a camera looking at, in this case, I've got bottles of beer going down a conveyor belt, and maybe you have a camera looking at those to determine, is the cap on the bottle, is the label on the bottle, things like that. On the other side, we have our medical machine vision, where we're going to be looking at something more. You're going to see a lot of test tubes in this presentation, which is a lot of things that we've done in the past. So you're really not looking at it in an industrial environment. It's more something embedded down inside a machine, used to help that machine function. There's some really key differences between these two types of applications. Well, the first thing you're going to notice here, a lot of the images you're going to see in this presentation, you're going to look at them and it's not like an image that you're going to see out of a digital camera. So we often set up the camera in the environment to get an image that's maybe not what a human for human viewing would like to see, but what's something the camera is going to like to see. So we're going to try to really make, for instance, on these test tubes, we're going to really try to make that outline pop. And so we've really tried to de-emphasize the background and even de-emphasize some of these other features on the test tube. So you're going to see that in a lot of these images. But back to the difference between medical and industrial machine vision. In industrial machine vision, again, it's sort of a standalone product. You're gonna put a camera and maybe a lighting system on the side of a conveyor belt or someplace on the factory floor. In the medical machine vision, we're talking usually an OEM product, so that camera is embedded down in some kind of other device that is performing some kind of other function. On the factory floor, maybe you have 10 assembly lines or something, so you're going to get 10 systems. You're going to put them in, and say you add another line later on, and that next camera system is slightly different, but you can tweak it. The manufacturing engineer is going to make it work like the other ones, and that's all okay. In the OEM or medical machine vision, for instance, this device, it may be making thousands of devices a year, and that device has some kind of FDA certification with it. So the OEM manufacturer is going to want every one of those cameras is going to be exactly the same. It's going to have revision lockdown. It may be a system that's going to be on the market for 10 or 15 years, so it's got to have a really long life cycle. And the last thing I want to mention is, as I set up at the beginning of this slide, maybe these bottles are coming by at 10 a second. And so you have to have a very fast camera and very fast processor to keep up with that. But that goes along with the other thing I said. Maybe you have 10, maybe 20 assembly lines, so the cost per unit probably won't matter that much. Whereas in an OEM device where you're making thousands of units a year, that cost can be significant. But generally, you don't need the kind of speed you're going to need over here with the industrial device. So you can sort of right-size the cost. Maybe you only need to deliver a result once per second instead of 10 times per second. So you don't need to design in that extra horsepower and cost that you would have with this device. I can't get advanced. Okay. Next slide here, we're going to talk a little bit about some of the things that we can do with machine vision. One thing is just comparing one part to another. Comparing it, is it there or not? So as in this graphic, we show some test tubes, and we're trying to detect if the cap is on or off. So maybe this is a case where you're trying to pipette from these test tubes, take a sample out of them, and if the cap's on, you're going to have a crash, and you could have some problems. So really just is something there or not? Next thing is it the right part? So you'll see some demos later where I'm going to do some actual shape detection where I'm going to look at a couple different things and try to tell one from the other. We can do color detection, whether that's color of an object, again, like a test tube cap, although it's a black and white image, it could be a color image, and we could be trying to detect that color. Or the color of the sample, for instance, say if there's a blood sample in this tube and we're trying to make some quality assessment about that blood sample before the actual diagnostic test is run. And then we can actually measure parts. So in a medical application, one of the things you might measure is you take a pipette and you pipette some blood or some urine or something out of a sample tube, and you want to measure, did you get enough sample? Did you sample enough in order to make an accurate diagnostic measurement?
Hey, Scott. We actually had a really interesting question about this slide. What is more common, color machine vision or black and white? Does it matter which one I use, and how will it affect the cost?
Good questions all the way through. So generally, we've seen more black and white machine vision, although color is not uncommon, but we've seen more black and white. So if you're just simply taking a presence absence or a width of a test tube and so on, you wouldn't need a color imager. You asked question about cost. And cost, we don't see a significant difference in color versus black and white. What we see more is the black and white cameras tend to be more sensitive. So we could keep exposure times lower because we don't have color masks over the pixels. So we'll generally stick with a black and white camera if we can. But of course, we'll switch to a color camera if you need to actually take a color measurement. There was another part to that question. Did I miss anything?
Does it matter which one is used, colored or black and white?
Well, yeah. So obviously, if you need color, you've got to use a color camera, and then the black and white would be the reason I just said for if you need for higher sensitivity, especially if you might have some motion in your image, you want to keep your exposure times really low, you'd go with the black and white camera. Okay. I think that's that for that slide. So benefits. Without reading all the words on the left there, one of the biggest benefits of machine vision is somehow taking over a job from a human. And there's two reasons you could do that. One is to lower labor costs, of course. So we're hearing more and more, especially in the healthcare world, where skilled labor, skilled lab technicians and so on are harder to come by. So our customers are asking more and more to use machine vision so that they can accomplish more with the people they have. Of course, the other part that goes along with humans is reduction of error. Humans, as much as we love them, they make mistakes, and so machine vision can eliminate that. A couple other things, you can improve automation, so that's all around going faster and getting better throughput. So a lot of the systems that we integrate our cameras into are automated systems. You imagine a sample moving through a clinical blood analyzer that's going to be all automated. You're going to use machine vision in order to make that automation more efficient and quicker. Reduce fraud, I'll talk a little bit about that later, but we have actually used machine vision to detect if the right part is installed. So if it's an actual authentic part versus a counterfeit part. And system optimization and providing enhanced data. I'll talk a little more about that later, but we can actually use a machine vision camera to eliminate other parts in the system that we're really trying to do the job that the machine vision can replace. Well, here's an example of that coming right into it. So in a typical clinical analyzer, where you're going to have a setup something like this, where you have a carousel with a whole bunch of test tubes on it. Those test tubes are still all encoded with linear barcodes. So you'll have a linear scanner, like I show here, to read the barcode. But then you'll have other sensors around the system to determine, what's the height of that test tube? Is the cap on or off? What's the width of the test tube? Is the tube even present, or is that an empty slot in the carousel, and so on? Well, what we can do with machine vision is we put in an image-based barcode scanner, all right, so a camera that can read that barcode, still read that linear barcode, but then it can replace all those other sensors around the system. So even though maybe the imager is a little more expensive than that linear scanner, since you can eliminate a bunch of other things in the system, you can end up with a lower overall system cost and a smaller footprint and some of these other benefits that you see at the bottom here. So with that, some of that background on machine vision, now we're going to jump into some case studies, some typical kind of projects that we've seen done and that we've done ourselves, and go on. So as I mentioned earlier, you're going to see a lot of test tubes in this presentation. So we've used machine vision a lot in the in vitro diagnostics world for looking at test tube samples to improve automation of a machine. And all these functions that you see on the page. So is the cap on, the cap off? What style of cap is it? Maybe you're going to do some kind of automatic decapping. You need to know if it's a pull-off cap or a screw cap. What size is the test tube? These test tubes come from doctors' offices and hospitals all over the world, and they can be all different sizes and shapes. You're going to need to know how to grab those in order to move them through the system. Of course, read the barcode, but in addition, we can say, well, we could detect that tube's there, but maybe detect that there's no barcode present. So, maybe it's turned around, and you can alert the operator to fix that particular error, and so on and so on. It's very typical machine vision functions. Liquid level detections, something we're seeing more and more need for in the imaging world. So in a test tube like this, we're going to detect, where is the level of that liquid? Do you have enough in there to do a sample? Where do you reach down to pipette? How far do you have to reach into that test tube? In addition, as you can see by the little graphic I just brought up, we can get very refined here and measure the amount of splashing or of the liquid on the sides of the test tube. We can detect things like froth or bubbles. I'll go into that a little bit more, I think, on the next slide. So that's all very common functions that where we see machine vision being used. Oh, might have another question here.
Yes, we actually have a bunch of questions, but I think you're going to get the answers of them in a little bit. So, but one question we did just have come in: how accurate can you get with machine vision volume measurement? Is it around plus or minus 1 milliliter? Better than that?
Well, that's a sort of a complicated question, because plus or minus 1 milliliter, it's really going to depend on the size of the vessel and is the container. And as you take a milliliter out, how much does that change that level that we see? So we usually talk in terms of distance, you know, so say plus or minus a millimeter or plus or minus half a millimeter. Then you use that to back in to say how much, as you remove a milliliter of liquid, how much of that level change do you see in more of a linear distance? How accurate can you get? It really depends on what kind of camera you want to use. So if we came in with a specific camera, let me just throw out a megapixel size camera, and that didn't have the accuracy, well, with more resolution, we can get more accuracy. We can see finer detail, if you will. And so that's really part of the system design that I'm going to talk a little bit more up front, is what are your requirements, what kind of accuracy do you need, and then we right size the camera for that particular application. Was there another one? No? Okay. You know, I mentioned physical measurements previously, and in this application, you're seeing a syringe. And what we've done several times, whether it's in an automated syringe filling system or an automated syringe dispensing system, where we can measure the size, the width of that syringe and the position of the plunger, so we can actually figure out how much liquid has been either dispensed or put into that particular syringe. So that's one of the areas in the medical world where we use those actual physical measurements that I talked about previously. By the way, a lot of these graphics you're seeing, this is from some machine vision software that JADAK has that we use to develop our machine vision algorithms. I'm going to go through that a bit later with a demo. So color measurement. We had a question about color measurement previously, and again, with the test tubes, we see a lot of times where this test tube may be going through an automatic tube sortation system, and the color of the cap on the test tube has some significance to how that tube needs to be processed in subsequent steps. So we can use the machine vision to actually grab, first of all, we're going to find where that cap is in the image, and then we're going to take a sample of the side of it to sample where the color is and determine back to the host system, yeah, that's a red cap, or that's a yellow cap, or a blue cap. Today, that's done in the lab by a technician holding up the test tube to a color chart and determining what color and somehow punching that into the system, where we can automate that now and eliminate the errors. In the liquid level detection slide, a couple slides back, I mentioned that we can detect, you know, splashing on the side of the tube. We can detect bubbles, or as I'm calling it here, froth on the top of the sample. And you can see in these graphics various test tubes with various levels of froth. And what we were doing for this customer is determining where that froth is. You could do it from the top here, like I've shown, to determine where the froth is, or from the sides to determine how thick the froth is. Again, all with the point of trying to come down and sample that particular sample to get a good sample and not get froth, really, to get the actual blood. So in the diagnostic results, we actually have also seen machine vision used to deliver the actual diagnostic results. And here's a case of that in these kind of lateral flow diagnostic kind of tests. If you're not familiar with lateral flow diagnostics, think of an early pregnancy test where you're putting a sample on some kind of a sample cartridge, and you're going to get a color change or a shape change based on the contents of that sample, based on its characteristics. They all tend to have a similar setup that I've shown here. So in this case, we have a dot that's a reference dot, or it could be reference stripes as shown on the other image here. And then we have an area that's going to change color or change shape. Usually we'll see a color change or a grayscale change based on, again, on what's in that sample. And we can use machine vision. We've done that a number of times to take a look at that and deliver to the system, okay, here's the color change of the dot based on the reference dot. It's higher, it's lower, this much percent away from the reference dot, and so on. Again, to eliminate a human having to look at that and make the decision. Talked about automation a few times, and here's a case where we're actually being very tightly integrated with a device to assist the automation. And here's a case where we have a camera mounted right on a robotic gripper that's going to come down and grip this test tube, and we're trying to avoid that gripper crashing into the test tube and breaking it. Then you get a biological sample spill within your device, which, as you can imagine, is a big problem. What we're showing here is that the blue crosshair is the pre-calibrated center of the gripper arms. The red dot is the measured center of the test tube. So in this case, we're going to send some information back to the robotic gripper saying, hey, move in this direction in order to get a better matchup and get better grippage on that test tube. And I mentioned briefly counterfeit detection in the past, and how we've generally done that with machine vision is through the detection of a logo. So a lot of our customers make the bulk of their money not through the sales of the device itself, but through the sales of whatever consumable goes in the device, whether that's a reagent, whether it could be a sample cartridge, it could be any number of things. And a lot of times they'll have their logo on that, where a counterfeiter will replicate the device, but they may stop short of replicating the company's logo, which can tend to bring a lot of different trademark infringements and different kinds of legal ramifications down. So in this case, we can actually detect that logo to make sure it's there and that it's the right logo. Now, we also have a different webinar. We've done it several times where we see RFID used for that application. It actually can be even a little bit more effective than machine vision. So I'll just mention that, and just Justina will be sending out some other invitations to that webinar in the future. Okay, so that's a few machine vision case studies that we see done. That's just a scratching of the surface. There's many, many more, and really what we try to tell our customers, if it's something that you see and can do with your eye, we can really try to make machine vision do that same thing. We still our engineers still haven't gotten as good as God. We haven't been able to make a camera that works as good as the eye or it's as good as the human mind, but that's generally what we try to say, is if you have a human looking at something today making a judgment, we can try to make machine vision do that. Okay, so a typical machine vision project is going to look a lot like any other engineering project, but it's good to remind everybody. So first thing is you start out with your requirements. What do you want to do? Now, there's some specific things that in a machine vision project we really need to take care of to have set up front. Was mentioned in the question earlier, what is your measurement accuracy? So if you're measuring liquid level in this test tube, do you have to know within a millimeter, a half a millimeter, a quarter millimeter? That's all going to determine what kind of camera, with what kind of resolution we use. What's your required throughput? As I mentioned on the slide way back in the front with the industrial machine vision, if you want a result every 100 milliseconds versus a result every second, of course that's going to regulate what kind of a processing system you have to have connected to that camera. One that's maybe not as thought of as much, but what is your acceptable success or error rate? So as I mentioned with the passive versus active machine vision, a lot of the objects we're looking at here weren't designed to be looked at by a machine, and so we have to develop the machine vision algorithm to look at. Now we can definitely approach the kind of success rates or get to the same kind of success rates that you see with active machine vision, say barcode reading, where you're in the 99.999% accuracy range. But the more accurate you want to be, of course, the more requirements it puts on your project for the upfront design and test, just like any engineering project. I'm going to talk a little bit more detail on that test, which is a very, very important thing. Another thing is, what do you want the machine vision system to do in the case of it's an ambiguous measurement? So say you're measuring a test tube cap, and you get an answer that says, boy, it could be A or B. Well, sometimes A or B, you're gonna treat that particular cap the same way in subsequent steps in your automated system, so it doesn't matter. Well, sometimes it matters a lot. Maybe A is a pull style cap and B is a screw-on cap. So in that case, you can't have that ambiguity. So what do you want the system to do? Should the machine vision try again? Maybe try a different algorithm in order to differentiate those two caps, or maybe notify the host to intervene, and the host and the operator can come over and make that change. Again, those different kinds of activities, when defined up front, can help you really get the best result at the end. In the system design, it's very important. You know, occasionally we'll get one of our OEM customers will come to us and say, boy, I've got my machine all designed, and we got to put a barcode reader and a machine vision camera in here, and they give us a corner to work in, and away we go. Well, we can generally make that work. It's better to be involved up front if we can to help design the system to get the best image to the camera, as I mentioned previously. And the graphic I showed on the right sort of illustrates this. Imagine that this is a test tube in the image on the most right image. We're trying to determine the shape of that cap, but in the background you see we have these other test tubes and so on. Well, we can make the machine vision work to figure out the shape of that cap, but as you can imagine, it's a little harder to pull that out from that background, as opposed to the middle case where we do have a constant background, there's no test tubes in the back, and now we can more clearly see that shape. Or in the very best is one we showed on the right, and as I mentioned previously, we put in say a retroreflective background where we're really going to make the shape of that test tube and that cap pop. And that's a case where we put in the best system design that we could up front, really to make the machine vision. First of all, it's going to make the project a lot easier and less costly, and you're going to get better results in the long term. Along with, you know, background, we've got lighting, we got the camera angles and distances, and so on and so on. I could go on, but there's a lot of things that, again, if we can consider the system design up front, we can deliver you a better result. This slide is illustrating how do you want to execute your project. So way on the left-hand side here, we have, you could come to your vendor, someone like JADAK, and they could provide a full turnkey solution. So you maybe deliver one of your devices or a portion of the device and the samples that you need to take a look at, and then that machine vision vendor is going to come back with the full solution for you. Way over on the right-hand side would be the other case where we have customers that say, well, we want to do the whole thing ourselves. So JADAK, just deliver us a camera, deliver us some tools to help us set it up and get the machine vision working. But we want to do everything because we want to learn about it. We want to maintain that going forward. Now, the downside of that part is that now you own it, though, right? So you have to provide the engineers to do that work, and then for subsequent maintenance steps down the road, you have to have somebody available that's going to make changes for you. What we're seeing more and more is customers say we want to do a hybrid approach. They come to someone like JADAK, and they're going to say, boy, I'm not a machine vision expert. I would really like help getting the project up and running. So JADAK, can you do that initial machine vision for us? But then we want to take it over, and we want to understand enough so that we know what's going on, and then we have confidence that everything's working the way we need it to. I'm going to talk through some tools later that help you to do that, but that's really, again, more and more we see that coming up. And the point is you want to find a machine vision vendor that can work anywhere along the spectrum to really tailor the project the way you want to work it. Looks like we have a question, maybe.
Yeah, Steve. A great question just came in from Steve. Based on the case studies here, can you provide an example of each time JADAK has helped with the outsourcing or the hybrid approach or the DIY approach?
Well, an example of each would be, that would probably take us the rest of the time that we have, but in any of those cases, we've done it any of those ways. So most often, like I say, in the past, probably 2 or 3 years ago, it would have been over here where the customers are coming to us and asking us to do the whole thing. We're in this middle ground here where, again, today is most often where we have the example where the customer says, boy, we want JADAK to help us get started, but then we take it over. Probably the most rare is where we have a total do-it-yourself over here. It happens now and then, and there's some customers that have good machine vision capability and knowledge, and they're willing to do the algorithms themselves and go on. So. Excuse me. Sorry, we're having a little trouble. There we go. There's my graphic. So, sorry for my clicking around there. What the graphic is trying to show is that once you've really got your upfront system set up and running, then you need to test. And I'm trying to illustrate that there can be a ton of different variations in the object you're looking at. So generally what we'll do is we'll grab thousands of images of the different objects that we're looking at in order to capture all those different variations. And like a lot of projects where we're going to, you're going to get the machine vision up and running relatively quickly, and you feel like, boy, we're almost there. I'm at the 95% point. But then there's that last 5%, which is all the testing, which can take a lot of the time. So I can't emphasize that enough. And really, we'll see in any of our machine vision projects that just when you get to the test phase, that takes really probably at least half of the time of the project. And that's similar to other non-machine vision engineering projects that I've been involved with in the past as well. Okay, so that's really the overview of a machine vision project and what it looks like. Now I'm going to talk about machine vision software packages. If you think back to the spectrum we talked about, back to this graphic again, where we mentioned that we're seeing customers ask more and more they want to do part of it, but they need a little bit of help. And these machine vision software packages, this is an example of JADAK's package. We call it Clarity, but again, there are others out there as well that we'll use to allow somebody who's not a machine vision engineer can set up a machine vision application. In fact, you don't even have to be a software engineer. You just have to be a reasonably talented technical person. And I'm going to give you an actual example of one of these. So here's a case. So here's a screen from our Clarity application. So I'll just do a quick walkthrough of the application here, then I'll go to the demo. I'll walk you through. Up here is what we call our widgets that I'll blow up at the bottom here. And these are the different functions that we have available. So we'll have a function for just simple presence, absence, is something there or not. We can count objects in the image. So for instance, in an automated pharmacy, say a pill counting application where you want to validate the number of pills you're dispensing. We can do a pattern match where we're not only looking at something there, but what is it the right shape? So we're comparing to an actual shape. We can set up a barcode decode, so we can say set up a window around a particular area to decode a barcode in that area. We can find specific shapes in the image, so a corner like this, a circle, a line. For instance, here you may find a line here and a line here, and then measure between those two lines with this next step. We can do some image processing, where we're transforming the image somehow to do some other measurements. Color detection, as I've mentioned several times. And then the last function, which I'm actually going to demonstrate, is output. Once you've got your machine vision application set up, how are you going to communicate those results to the host? And with that said, I'm going to jump over here to our Clarity application itself. Now here's a case, and what I'm going to do is a simple application here where I'm going to set up a test tube. I'm going to recognize the cap on that test tube. Now in this case, I've got a bunch of different images stored here. And usually you would start that way, where you're going to look at images on the PC, you're going to set up your application, but then we're going to send the resultant machine vision algorithm down to a camera where it'll run in an automated method in a machine. First thing I'm going to do is I'm going to select pattern match because I want to see this pattern right here. So I'm going to say pattern match. Now the first thing you notice is this is the area where I'm setting up my different steps for my machine vision. So that pattern match jumps down here, but now I have to set up how I want it to work. So I get this image comes up where I can position this window to say, okay, here's the pattern I want to see. And you can see this is the actual pattern that the camera is going to use to try to match in subsequent steps. Now there's a lot more here. There's a lot more functions that I could implement, but we just don't have time to go into that today, but maybe in a future webinar I can do that. So you can see, first thing you can see is I have a score for this pattern match. In fact, I'm going to change the name of it to be SARSTET. Sorry, it's easier to say than to type. And you can see my score is 100%. Well, that's because I'm matching an image to itself, so of course I'm going to get 100%. As I run the next image, which is slightly different, I still get a good score, but it's slightly different, down to 98, 98, 99 on that one. And then I get to one of my others, my Terumo cap, where I'm going to see, well, that I've got a bad match. It's not close. So now I'm going to have to set up another pattern match. Excuse me, for that one. So it's going to work the same way. I set up a pattern like this. And there's the pattern I'm matching. I'll accept. And similar to last time, I have 100% match on that pattern. Let's run through several. 98, 96, 96. And I'll change that name as well. And done. So let's run through. So the next thing I have is a test function. I mentioned testing. So I can run through all these images. Now in this case, this simple demo, I only have 10 images. As I had mentioned in the previous slide, you really would want to have hundreds of images of all these different test tubes and different variations and maybe some different lighting combinations and so on to make sure. And in this case, I got all the matches where I wanted the matches. And then you could send this out to an Excel file, for instance, to do further processing if you had thousands of images. So I'm going to go back to my original. And the last thing I want to do is I'm going to set up my output. Again, as I mentioned previously, so some way, once I have these results, I have to communicate them to the host. So this is just a graphical way where I can set up these things to go to the host. So first I'm going to enter a text block where I'm going to say SARSTET. Then I'm going to go to that SARSTET step, which is up here. And I'm going to grab the result and add that to the output. So now every time this script runs, I'm going to get the text string SARSTET, and then for this step, I'll get true or false. There's other things I could deliver. I mentioned the score that I have, the 100% and lower for each different measurement. I can measure the how much time it took. I think there's the center position of that pattern, and so on. And then the last thing I would do, I probably would add my Terumo. Well, let me change that. I'll add text. This says Terumo, and I would add the Terumo result as well. And I think you get the idea. Oops, result, and add that to the output. So again, this was just a really quick, simple example. You could do many more complicated things with this, but how you could, I'm not a software engineer at all. When I was doing engineering, it was all, I was an EE. But I can develop a machine vision application now on my own and test it and flash it in the camera and install it. And with that said, I think we're nearing the end of the presentation. We covered these different topics, briefly who's JADAK, but some background on machine vision, some case studies, really some, in general, what the steps you have to take in a machine vision project. talked about the Clarity Machine Vision Assist package. My contact information is up there. If anybody had a question that they wanted to send to me, I'd be very happy to field that and get back to you. Mute.
Had some great questions come in, Chuck, that I would like to read out loud to you.
Okay, sounds like we have some questions. I'm not sure if anyone can hear Justina, but go ahead.
What would I need to run Clarity in my system? A camera, anything else? What type of camera?
Yeah, so the question was, what do you need to run Clarity in your system? So to start out, what I'm just running it here is on a Windows PC. So that's how you would get it up and running to establish your initial machine vision algorithm. But then after that, you would need a JADAK camera to flash that algorithm down into the JADAK camera. Right now, Clarity does not work with another camera, say you had your own hardware. But again, back to where I talked about, you need to work with a machine vision vendor that's going to work with you the way you want. We would consider those kind of projects. Say you have your own camera today, but you wanted to add JADAK machine vision to that. We could discuss how we could make that work.
Cool. Thanks, Chuck. Those are great answers. At this time, I'd like to thank all of our attendees for joining the webinar. A special thanks to our presenters, Chuck and John, for their presentation. A recording of this session will automatically be emailed to those who registered for the event within the next 24 hours. Also, we encourage you to follow up with Chuck if you have any questions for him. His email will be sent to you automatically. Also, if any of our attendees are interested in a medical machine vision tech day, please feel free to email us at techday@jadaktech.com for a free consultation. Thanks again, everyone, for attending, and have a great day.